Hi, I'm Milind, and let's continue our discussion on factors of quadratic expressions. In the last part, we had seen how to find the factors by using the practical method. I had also given you certain quadratic expressions and asked you to find the factors using the practical method and try to see how you can get to a technique to solve these quadratic expressions. I had also given you certain hints to help you in arriving at the technique. Why are we saying that we need a technique? Because every time it's very difficult to use the tool, and if you have an expression as shown, you need too many pieces to form the rectangle. So what we need is a simple technique to find the factors. Let's take the first two expressions that I had given. Using the practical method, you would have a rectangle like this and this. And how do we find the factors for these? We measure the length and the breadth. So what are your observations for the first expression? In one of the hints, I had asked you to check how the middle term, that is 8x, is getting split. So if you see, the 8x is getting split as 5x and 3x. And also, if you see the arrangement of the 15 units, they are arranged as 5 columns and 3 rows. So do you see any relationship between the way the 8x has been split and the way the 15 units have been arranged? For the second expression, what are your observations? The 8x has been split as 4x and 4x. See, deliberately I have kept the middle term as 8x in both the cases. In one case it gets split as 5x and 3x, whereas in the second case it gets split as 4x and 4x. You should think, why is it so? So in the second expression, the 8x is split as 4x and 4x. And how are the units arranged? The 16 units, they're arranged as 4 columns and 4 rows. And in the second hint, I had mentioned that we need to, once we get the factors of the quadratic expression using the practical method, we need to multiply those factors to get back the quadratic expression. And this you can do by the binomial multiplication, which you are very familiar with. And now what we need to do is go through these steps in the reverse order. So we write the quadratic expression first, then the next step, and here we see that we have split the 8x as 3x and 5x, which we can clearly see from the rectangle on the left hand side. We group the first two terms and the last two terms. So the first two terms, that group represents the left side of the rectangle, and the last two terms represents the right side of the rectangle. And then here we are going to use a simple technique where we say that if we have 6 apples and 6 mangoes, this is similar to saying that we have 6 boxes of an apple and a mango. So what we have done is we have taken 6 as common here. So similarly, in the two groups that we have formed, we have to find out what is the common factor. So in the first group, x is the common factor. In the second group, phi is the common factor. And we write the remaining terms. And here again, we use another technique where we say that if we have 2 boxes of an apple and a mango, and we add 7 boxes of apple and mango to this, what we will get? We will get 2 plus 7 boxes of apple and mango. So x of x plus 3 plus 5 of x plus 3 would give us x plus 5 of x plus 3. And in the second expression, we have split the 8x as 4x and 4x. We group the first two terms, which is the left side of the rectangle, last two terms, which is the right side of the rectangle. We again take common factors. So x is common in the first group and 4 is common in the second group. and then x of x plus 4 plus 4 of x plus 4 gives us x plus 4 of x plus 4. So actually the technique to find the factors is to find how the middle term is to be split. And if it is very clear that the way the middle term is split depends on the constant term, right? So what is the technique for splitting the middle term? So your answer would be, take the constant term and find two factors such that the addition of those factors gives you the coefficient of x. So let us see this in the two examples that we took. So in x square plus 8x plus 15, what are we going to do? The constant term is 15. So what are the two factors of 15? So you'll get various sets of factors. So 15 and 1 are also the factors, and 5 and 3 are also the factors, because 15 into 1 gives you 15 and 5 into 3 also gives you 15. But which set of factors do we choose? The middle term, that is the 8x, will help us decide that. So when we add 15 plus 1, we get 16, but the middle term is not 16x, it is 8x. So if we add 5 and 3, we get 8x. So we choose 5 and 3. And in the second example, what are the factors of 16? 16 and 1, or 8 and 2, or 4 and 4. And which set do we choose? We would choose 4 and 4, because 4 plus 4 gives us 8. So you show that this is the technique that we should use for the split. Let us see. Now let's just take the remaining two expressions that I have given. Can we apply the technique that you have found out for these? If you see, the constant term in the first expression is 3, and if we take the factors of 3, do they add up to 5? They don't, right? So how do we find the factors of these using the technique? So we can start from the practical method. We'll find out what are the rectangles for these, and then what are the lengths and breadths. So we have found the factors by using the practical method, and now we will check what are our observations. So if you see, the 5x has been split as 3x and 2x. And what about the constant term 3? The 3 units have been arranged as 3 columns and 1 row. So previously, if you have observed that the way the 5x was split, the units were also arranged in the similar number of columns and rows, but here they are not. The second expression, the 5x has been split as 4x and 4x. And how are the two units arranged? They have been arranged as 1 column and 2 rows. So does the split of 5x depend only on the constant term, or does it depend on something else? So if you see in the first example, the two x's on the bottom side have been split across the two x squares, and the 4x's on the bottom side of the second expression have been split across the two x squares. So is the coefficient of x square also playing a part? Now solving the expression to find out the factors, we have 2x squared plus 5x plus 3. So the 5x has been split as 2x and 3x. And then, like before, we again make two groups and then try to find out what is the common factor in the two groups. And then we have 2x of x plus 1 plus 3 of x plus 2, x plus 1 gives us 2x plus 3 of x plus 1. What about the second expression? The 5x has been split as 4x and x, and again we make two groups, take the common factors, and then 2x of x plus 2 plus 1 of x plus 2 gives us 2x plus 1 of x plus 2. So you can see that the factors are indeed the same ones as we found out practically. So now the split of the middle term no longer depends on only the constant term. It also depends on the coefficient of x square. So now what is the technique for the split? So take the product of the constant term and the coefficient of x square, find two factors such that their addition gives us the coefficient of x. So let us see how we can apply this for our examples. So 2x squared plus 5x plus 3, the product of the constant term and the coefficient of x square is 6, and the factors of 6 are 6 and 1 or 3 and 2. And which set do we choose? We would choose 3 and 2. Similarly, for the other example, constant term is 2 and the coefficient of x square is 2. So 2 into 2 is equal to 4, and the factors of 4 are 4 and 1 or 2 and 2. Which ones would we choose? You would choose 4 and 1 because 4 plus 1 gives us 5, which is the coefficient of the middle term. So is this the final technique? What do you think? Yes, that's the final technique, and this technique is applicable for quadratic expressions in one variable. So the only variable which we had in the expressions which we worked on was x. So let's try out our new form technique on one of the quadratic expressions, 3x squared plus 8x plus 4. So now you start telling me the steps one by one. So what do we do as the first step? Take the coefficient of x squared and the constant, multiply that, find the product, and then find the factors of the product. And which set of factors do we choose? We choose the ones whose addition gives us the middle term. So we choose 6 plus 2 because 6 plus 2 gives us 8, which is the coefficient of the middle term. And then how did we solve this? How did we find the factors? We wrote 3x squared plus 8x plus 4 as this, where if you see the 8x has been split as 6x and 2x, and then we grouped the terms, took the commons, and then got the factors. So what you can do is you can also try to do it using the practical method and see if you get the same factors. And one more check would be to multiply these two factors to see if you get back the original quadratic expression. One question that the children have is, how do we write the split of 8x? Is it always in a particular order? Is 8x split as 6x plus 2x and written as that, or can it be written as 2x plus 6x also? So let us find out. So here we have split it as 2x and 6x, and we see that we get the same factors, and since multiplication is commutative, these are indeed the same factors. So we have found out a technique for finding the factors of quadratic expression in one variable. And the way of writing a quadratic expression in the standard form is ax squared plus bx plus c, where x is the variable. A, b, c are numerical values, where a and b are the coefficients of x square and x, and c is the constant term. So in this example of ours, what will be the value of a? It will be 3, the value of b will be 8, and the value of c will be 4. So now you will be able to solve all quadratic expressions which are of this form. So see you in the next video for more on quadratic expressions.